we're going to work with the next kinematic equation. First, we're going to read it to see what question are we trying to answer. It says, if an object accelerates from rest with a constant acceleration of 5.4 meters per second squared, what will its velocity be after 28 seconds? Well, first thing first, what are we trying to find? Because it says, what will the velocity be after? We know that we're going to be then looking for its final velocity. There are other details given to us, such as it accelerates from rest, that means it started at rest, and then it started to move. We know that the acceleration after it started to move is 5.4, and we know that 28 seconds is how long it took. So that means we have our starting velocity. It was from rest, so it's going to be 0. We have our acceleration, which is established to be 5.4, and we have our time, which is 28 seconds. The equation that we're going to need will not be the first one, being that acceleration is part of the problem. Will it be the second one? Let's see. We know we're looking for final velocity, so that checks off. We know it starts from rest, so the starting velocity is present. We know that acceleration is a part of it, and we know that time is a part of it. The reason why it would not be the other problems is because with this kinematic equation, which is via final velocity squared and all that, displacement is here, so it's not going to be that. With this equation, we know that acceleration and time are included, which they are not here. And with this, we know that it is asking us to find final displacement, which is not part of the problem. So therefore, this kinematic equation becomes what we use. So now that we're here, we can replace our variables and say, well, 0 plus 5.4 times 28 gives us VF. We do not need 0 in this moment because 0 plus any number gives you that number. Just like 0 plus 5.4 gives you 5.4. So in this moment, we can simplify by just kind of removing the 0 and focusing on our number 5.4 and 28. 5.4 times 28 will give you 151.2. So therefore, the final velocity in this problem is 151.2 meters per second.